Hi, and welcome to Unit 1.1, Foundations of Chemistry, Part 2. Just like in the previous video, this video will focus on key terms, and it's super important that you annotate anything that you need to annotate. So I just want to quickly recap where we ended off on part 1 of the video, in case it's been a while since you've seen it. We looked at how matter is classified. There are basically two main branches of matters, mixture and pure substances. There are two types of mixtures, homogeneous, that's the one where they all look the same, homo meaning the same, and heterogeneous, where you can see the difference using your eye or a microscope, hetero meaning different. The other branch is pure substances. That means there's only one type of thing or substance in it, whether it's an element or a compound. And those are the two types of pure substances. So we're going to focus on pure substances, and we're going to focus on classifying pure substances. You are probably already familiar with these classifications. Here are some terms. Take a look at them now. The one type of pure substance you may not be familiar with is probably network covalent, but you probably like it. If you like bling, you like network covalent because diamond actually is an example of network covalent. Also, the pencils that you use utilizes graphene, which is an example of network covalent. So you actually know more about network covalent than you think you do, but this is another type. Although we don't talk about this much in AP chemistry, it is kind of useful in some particle diagram questions for the AP Chem exam. Okay, so why is it important for us to classify anything? You've probably seen this example before. I use it often, pickup truck versus sports car. So if you were trying to figure out which vehicle to use in a race, or which one would you use to move a couch without even seeing the vehicle, if someone said, oh, I have a pickup truck or I have a sports car, you would probably be able to make a fairly good decision. Why is that? Just the same way that in vehicles, we can classify things based on certain shapes or features, and we can utilize that understanding to make predictions about how that vehicle will perform. The same thing is true for pure substances. Now you may be thinking to yourself, well, it totally kind of makes sense for a vehicle because yeah, I need a vehicle, I use it, blah, blah, blah. But what about pure substances? I just want to give you a quick run through and a really cool example of how classifying pure substances can be helpful. First off, different types or classifications of matter will have similar properties. For example, group 17 halogens, so that's starting with the group that starts with fluorine. They all have very similar chemical properties. They bind to metals in very similar ways. They oftentimes want to gain electrons, not lose electrons. So they have very similar chemical properties. Metals, for example, have similar physical properties. So metals are shiny, they're malleable, they're ductile, most of them are solid. So those are some physical properties that are the same. So when you think of a metal, you think of something that's solid and shiny and you can bend it. And that can help you to determine whether or not you want to use a metal for something or you want to use a non-metal. So the example I'm showing here is silicon, and you may be thinking, well, what does this have to do with anything? Here, this is one of the very first computers that we used to use. Look how big it is. Now, I'm not talking about just this or just this part. I'm talking about the entire room was the computer, okay? Computers used to be huge because they used to use these sort of light transistor things. And transistors are the switches inside of the microchips. But it turns out semi-metals or metalloids like silicon have the right conductive properties, since they're semiconductors, that you can utilize them to make switches, and really, really tiny switches. So the properties of these semiconductors, silicon and a few other types, helped scientists to develop really small microchips, which then meant that computers went from being the size of a room to being something that you can fit in your lap or actually in your pocket, because your phone is essentially a computer. So let's talk about the properties of matter. There are two main types of properties: Physical, that's something like density, melting point, which is the temperature at which something melts, boiling point, the temperature at which something boils, conductivity, whether it conducts electricity or heat, etc. And there's also chemical, so that includes reactivity, whether it's reactive or not, and those would be things like, does it combust? Does it rust? Is it radioactive? Is it toxic? And each of these properties can be either intensive or extensive. This is sort of a side note, so you can choose to read it or not. I won't really go into it. But these are the main types of properties of matter: physical and chemical properties. So how do we classify or determine the types of properties? Take a moment to look at this flowchart, and then we'll go through a few key points. So going back to the very beginning of part 1 video, we were talking about how chemists and scientists study the properties of matter. And so if it's a physical property, you can study that physical property without changing the matter. You can look at the color of something without changing it. You can test the conductivity of something without changing it. So that would be a physical property. And there are different types, again, broken down to the intensive and extensive, meaning independent of amount, and extensive, meaning dependent on amount. We won't really go into that too much, but just consider all of these as physical properties. On the other hand, if you study the property of a substance, and by studying that property, you have to change the substance, then it's a chemical property. So for example, if you wanted to test to see if a metal will rust, and you leave the metal under conditions where it will rust, well, once it rusts, it's no longer metal. It's an oxide of that metal. So you have now changed it from metal to some sort of oxide, which is the rust. And so you're studying a chemical property. So these are all examples of chemical properties. Okay, so we're talking about all these properties, and there are different properties that molecules have. Well, what's the basis of these properties, and how do we help to distinguish how these molecules are classified? And that's by the types of bonds. So, and typically you can identify the types of bonds by the types of atoms. So metals have all metal atoms for the most part. Metalloids and semimetals are found in this part of the periodic table. And then you have your non-metals, which are found to the right. This is something that's super important to know about where the metals are and where the non-metals are, because that's going to help you to understand and explain properties. So properties of metals, they're solid, shiny, malleable, ductile. Malleable means that you can bend it, and ductile means you can pull it out into a wire. And most metals conduct heat and electricity. The thing about metals in terms of one of their chemical properties that you need to know is that metals tend to like to lose electrons. On the other hand, nonmetals, which are sort of the opposite of metals, they're dull, brittle insulators of heat and electricity, meaning they don't conduct heat and electricity. Nonmetals like to gain electrons, so they react differently. So one of the trends that is really helpful when thinking about what's happening in a chemical reaction or explaining periodic trends, which will come later in the year, is that I always like to think that this metal right here is the most metal you can get. And as you move towards this metal in the periodic table, then you are going to want to lose electrons more. You're more likely to lose electrons. On the other hand, this element, fluorine, is the most non-metal you can get. And so the closer you are to fluorine, the more you're the type of element that wants to gain electrons. So these sort of trends are, again, going to be helpful when you're trying to figure out what's happening in a chemical process or change. Okay, so how do we classify these pure substances? Just a quick recap. You're going to use your atoms. If it only has metal atoms, it's a metal. If it has a metal and a non-metal, it's ionic. Remember, NH4 plus is sort of our metal here because it's a cation. Non-metals can make covalent molecules, and we sort of break those down into nonpolar covalent and polar covalent. So nonpolar means that it does not have a dipole moment, meaning that it does not have a positive and negative side. So no positive and negative side here, and polar has a positive and negative side. The last one, which we briefly mentioned when we talked about diamond, etc., is network covalent. That's when covalent bonds are arranged in a lattice or a network. And so if you ever look at diamond, it looks like sort of like just a network of carbons. Okay, so what do you have to do with this CFU? Essentially what it is a flow chart that's sort of set up for you. And your job is to fill in this flow chart by connecting boxes. So for example, here, I would draw a line down here and then one over on this side and draw a line over on that side. And then I would be asking myself, metal atoms or NH4+. So if I say yes, that it does have metal atoms or NH4+, would I go to the non-metal question underneath which is metal and ionic, or would I go to the next section which acts of its bonds in a network and where you have the covalent molecules? So I want to try and test your ability to sort of organize this data on your own, or this information on your own, by trying to create this flowchart. We will review this flowchart in the next class, so don't freak out. If you're not really sure what I mean, just come and check in with me before class. Finally, before we just do a quick summary, I'll oftentimes use the word molecule and compound. I just want to be clear about what they are, because sometimes they seem to be interchangeable and sometimes not. So a molecule is any substance with more than one atom, and that could be the same atom or a different atom. For example, let's say this is a molecule of H2O. This would be considered a molecule. But it also can be considered a compound, because a compound is a molecule where the atoms are, where you have different types of atoms, two or more different types of atoms. So that means that molecules can be compounds, but compounds cannot be molecules. For example, this, where there's only this, it's the same type of atom, you can call it a molecule, but you couldn't call it a compound. Okay, so I just wanted to summarize. These are the key terms that were presented here. Not that I'm going to be testing testing you on these right away, but these are terms that we're going to be using in this class. So you should definitely get comfortable, get used to them, just get sort of familiar. All right, folks, I hope you found this video helpful, and have a quality day.